All right. So today, do we need to go over questions on the homework? Yeah? Well, we need to do that and this and... Okay. Okay, so we will end up talking about last night's homework as we go over this. Let me spell this right. And let me put the right title on it. Okay, so we talked about arithmetic sequences. Arithmetic, remember, was when we add the same thing over and over again or subtract the same thing over and over again. Today, we're going to talk about series. A series is where we have a sequence, but we add the terms up. So if I look at this sequence, this series, plus 9 plus 10, can you tell me what this equals? Figure it out. Okay, so there's several ways we can add this up. One way is to just add them up, but Maria saw 9 plus 1, 2 plus 8, 3 plus 7, 4 plus 6. So we saw 10, 10, 10, 10, 10. So that's 50 plus the 5 is 55. Okay? So there's one way to add up numbers quickly, right? You find the tens, and then you add up whatever's left over. Now another way, I want to show you a different way. See if anybody did that. Did anybody find a different way? The calculator. But even that could be tedious, right?
Yeah.
You did what? So Ashley did 1 plus 10 is 11. And 2 plus 9 is 11. And 8 plus 3. I'm having issues with 8 today. And 4 and 7 and 5 and 6. These are all 11.
I didn't see that.
You see it now? How many of those are there? 5 times 11. Why is there only 5 even though there's 10 terms? We divide by 2. Why? We're taking pairs. We're taking pairs. So we're pairing them up, and we have 5 pairs times the sum of the first and the last number. And this is our summation formula for an arithmetic series. We take S of n, the sum of n terms, is equal to the number of terms divided by 2 times the first term plus the last term. S sub n, subscript n. That is the sum of n terms. There's like a little mark that I made. Okay, so we're going to use our summation formula, S of n equals n over 2 times a1 plus an. N is the number of terms. A1 is our first term. An is our last term. To find the sum of the first 20 even numbers. The first 20 even numbers. 2 to 40, right? So our A1 is 2, because it says starting with 2. Our AN, or A20, our 20th term, the 20th even number is 40. And how many terms are we adding up? 20. So take a second, plug it into the formula, and get that sum. All right, do we have an answer? Yes? Your AN in this case is the 40. because that is the last term we're interested in adding up. So my sum for the 20 terms, we say S20 for the sum of 20 numbers is 20 divided by 2, right? N over 2 times A1 plus AN, which is 10 times 42, which is 420. Okay?
Oh no, I already see how this gets hard.
Wait, equals 10.
20 divided by 2 is 10.
Oh.
And then 2 plus 40 is 42.
I see what you're saying.
All right, so let's try the next example. Pay attention to the differences here, okay? Find the sum of the first 18 odd numbers starting with 1. So what's my A1 going to be?
1.
What's my N going to be? 18 is my N, the number of terms, right?
Yes.
And what is the 18th odd number? If you don't know, or if you know, let the rest of the group figure it out. So if we don't want to count odd numbers up to 18, we can use yesterday's formula, which is AN equals A1 plus N minus 1 times D. AN is what we're looking for, right? A1 is 1. I want the 18th term, so N is 18. And what is the common difference for odd numbers? 2, right? Don't they go up by 2? 1, 3, 5, 7, 9. So my D is 2. So that's 1 plus 17 times 2, which is 1 plus 34. So A18 is 35. And I'm having trouble making 8s. So if you didn't want to count 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, all the way up to 18 of them to get 35, you can use the formula. And you're going to have to do that in the homework tonight. You're going to have to use the formula to possibly find N or to find AN so that you can plug it into the sum formula. Now that I know AN, A1 and N, can I find the sum? That's 18 divided by 2, right? N over 2, 1 plus 35, which is 9 times 36, which is 324. The next thing we look at is called sigma notation. Sigma notation is a concise way of writing a sum using the uppercase Greek letter sigma. It looks like a funny E. You may have seen it before. There's a button, a sigma button in Excel, which will add up all the highlighted cells in Excel. Lowercase sigma looks like this. It's like a weird O with like a line on top. This is lowercase sigma. Uppercase sigma is that like funny looking E. Lowercase sigma we use in statistics to find standard deviation and variance, which is a measure of how spread out the data is. But in this class we use uppercase sigma mostly. So you have the sigma notation, which means sum. Find the sum. So these problems will usually just say evaluate, and it'll have that sigma notation there. Now, the bottom has an initial value, initial number you're going to start with. It's not always 1, and it doesn't always use the variable I. Sometimes it's K, sometimes it's N. The top is the last value you're going to use. And the formula is right here, this 3I. What this means is I have a series that starts with I equal to 1 and goes up to I equals 10. And the pattern is 3 times that number I. So we're going to write it all out and find it by hand. And then we'll use the formula. Okay. Okay? So when we write it out by hand, what do you think my first term is? If my first term means I plug in 1 to this formula, what's my first term? 3. Everybody agree? 3 times 1 is 3. So what should I plug in to find my second term? Say that louder. 2. Plug it in 2, and what do I get? 6. So my third term, 3 times 3, 9, plus 12, right? My fifth term, 15. My sixth term, 18, 21, 24, 27, 30. I'm going to go up to 10 terms, right? So my final term is 3 times 10, 30. This is writing the series out by hand. And then I can add it all up to find my sum. You will have to do one problem on the quiz Thursday where you are asked to write it out by hand and find the sum. Because we want you to understand what sigma notation means. Not just how to evaluate it, but what it means.
So you're going to use that.
And we're going to give you this, and you have to write it out like this, and then tell us what it equals. Okay? It won't be this exact problem, no.
So if it's I equal to 1, it's always going to be 2, then 3 next, then 4 next, and 5 next?
Right. If I starts with 1, then it goes 1, 2, 3, 4, all the way up to the top number. Now, I does not always have to start with 1. Sometimes it might start at 3. So you plug in 3, and then 4, and then 5, and then 6, and then 7, and then 8, and then 9, and then 10.
And there's no way it'll be like, oh, 1, then 3, then 5, then 7.
No, you don't skip numbers to write a series. So what do we get when we add this all up? 165? Oops. Now, how would the formula work and make this easier? Our formula tells us all I need is the first and the last term, right?
Yes.
Yes? So our formula, our first term is 3, and our last term is 30. And then I need to know how many terms there are.
10.
There's 10, right? Because I started at 1. So from 1 to 10, there's 10. So 10 divided by 2, that's 5 times 33, which is 165. Okay? That's how you would use the formula. With the formula, you only need your first term and your last term. And that's what we're going to use most of the time with sigma notation, is just find the first term and the last term. And then find how many terms there are. So let's look at some more. We're going to evaluate the sum of 2k plus 1. That's our pattern. That's the rule for this series. Starting with the k equal to 3, going up to a k of 10. So my first question for you is, how many terms are there going to be if I start at 3 and I go up to 10?
7, 6,
8.
okay.
It's 8.
Just including this.
Because you have to include the 3, right? So count on your fingers. Start with 3 and count to 10. No, 3 is 1, right? So 3 is 1, and then count to 10. How many fingers do you have up? 3, 4, 5, 6, 7, 8, 9, 10. 8 fingers, right? So there's 8 numbers if you start at 3 and count all the way up to 10. Because when you're subtracting, you're taking the 3 off of that subtraction. It's not included in there. And we have to include the fact that we're going to plug in 3, we're going to plug in 4, and then 5, and then 6. And so we're going to end up with 8 terms. So our n equals 8. And I really don't want to list them all out because that's a lot of work, right? So again, if I count 3, 4, I get 8 terms. Now here's the shortcut. It's 10 minus 3, and then add 1. It's always one more than the difference from the top number minus the bottom number. Okay, it's always one more than that difference because you have to include the number that you are starting with, which is 3. So I know n is 8. Let's look at our formula again. What other information do I need to know? I need to know the A1, my first term. So what am I going to plug in to find that first term? Plug in 3. So 2 times 3 plus 1, 7. What else do I need to know? My last term, which I'm going to plug in what? The 10, right? The last term is 10, so it's 2 times 10 plus 1, which is 21. So I plug in the top number for k to find my last term. And now I use my sum formula. S of 8 terms is 8 divided by 2 times 7 plus 21, which is 4 times 28, which is 112. Okay, so take a second and try the next example. If you're watching the video, you should be pausing it. Okay, so how many numbers are there? There are 5, right? If I count from 2 to 6, I get 5 numbers, so n is 5. How do I find my A1? Plug in 2 to the formula, so 3 times 2 minus 4 is 2. How do I find an? Plug in the top number 6. 3 times 6 minus 4 is 14. And the sum of 5 terms is 5 over 2 times 2 plus 14, which is 5 over 2 times 16, which is 40, no matter how you slice it.
Yes, I got 40.
Right? Whether I do 2.5 times 16, or I do 16 divided by 2 is 8 times 5, I still get 40. If I count 2, 3, 4, 5, 6, how many numbers are there? There's 5 of them. So you have to count how many numbers there are from 2 to 6 to get your n. Or you can subtract them, but you have to add 1, because when you subtract off the 2, you're not including it. Okay? All right, next example. Find the first 3 terms of the arithmetic series given.
Yay.
Here, we're going to have to use the 2 formulas together. In order to find the first 3 terms, I need to know the first term and the common difference, right? If I know how much I'm counting by, how much I'm adding or subtracting every time, then I can find the first 3 terms. So let's look at our 2 equations. Sn, n over 2, a1 plus an. And yesterday's an equals, there shouldn't be parentheses there, a1 plus n minus 1 times d. Now the second formula, this formula gives me d, that's what I need, but I don't have n either, right? So it's not a good idea to start with this formula because I don't know 2 of the 4 variables, right? But if I look at the sum formula, do I know 3 out of the 4 variables? So then I could solve for n, and then I can use that to plug into this formula to find d. So S of n equals 741, and that equals n divided by 2 times 9 plus 105. So 741 equals n over 2 times 114. Divide by 114 by 2 and I get 57. So 741 equals 57n. So n equals, somebody with a calculator, say it louder, 13? 13.
Could you do the, and it'd probably it would take way longer.
So now I need to find the common difference by using my second formula, right?
Yes.
So that's an, which is what? 105, right? An is 105 equals a1, which is 9, right? Plus n, which we just solved for, 13 minus 1 times d. So 105 equals 9 plus 13d minus, sorry, I did that wrong. That's 12d. I was going to distribute. There's no point in that. 12d. And then I can do what? Subtract 9. What's that? 96 equals 12d. Divide by 12. And d is 8. So if I know that my d is 8, what does that mean my pattern is?
Adds 8 every time.
I'm going to add 8 every time. So if my first term is what? 9. What's my second term? 17. 9 plus 8. What's my third term? 17 plus 8. 25. And that's the final answer I'm looking for. So give the next problem a try.